Hi, everyone. Thank you for coming today. So I thought I would start off by asking you a simple question. Are we in the wet season or the dry season right now? Anyone know? Wet season, definitely, right? And so, but how do we know that it's the wet season? What defines the rainy season? And how does that apply to agriculture, especially not only here in California, but in places farther away like sub-Saharan Africa and Zambia? So today I want to talk to you about the story of rain-fed agriculture. Rain-fed agriculture is one of the primary forms of agriculture in the world, where many small-scale farmers depend on it to produce food for themselves and their local communities. In Zambia, farmers depend on the start of the rainy season in order to plant their crops, which their primary staple crop is maize. If you couldn't tell by Michelle's lovely haiku, but increasingly there's been concerns about dry spells and drought during the rainy season that has led to crop failures, and that leads to concerns about famine and food security. And so how does climate change impact Zambia right now? It's currently experiencing, over the last 30 years, a slight increase in average temperature, as well as increased precipitation. But notably, there's been increased variance in the precipitation, both inter-year and intra-year. So not only is it harder to predict what year is going to be rainy versus dry, but when the rains actually start become hard to predict. And so using this as our framework, we ask the questions, in a world with a changing climate, how do farmers know when to plant crops for a successful harvest? Next, we ask, is the start of the rainy season a reliable signal for a successful harvest? And then how can smallholders adjust their planting strategies during the growing season for a successful harvest? And the way we answer these questions is by using the start of season rainfall date to obtain causal estimates in order to answer these questions. Specifically, the start of season is defined as a sufficient level of rainfall that's necessary for the germination of maize, and is commonly used in to predict droughts and early warning systems. So how do we answer these questions? First, we use the start of season to predict maize planting dates for farmers within Zambia. Next, we examine the relationship between the start of season and yield outcomes to determine if it is a reliable signal for a successful harvest. And then finally, we explore the number of times a farmer plants maize in conjunction with the start of season to determine if it's an adaptation to the uncertainty of climate change. And so why does all this matter? Why does the start of season matter? Well, the majority of global agriculture practice today is still smallholder farms. There's approximately 500 million smallholder farms globally that make up 80% of all people who call themselves farmers, and yet they only make up 15% of arable agricultural land. And in addition to that, they're very vulnerable to climate change and climate shocks. And so being able to understand what low cost, low technology adaptation strategies are actually successful and maintaining a strong yield outcome can help reduce food insecurity and increase rural resilience in the light of a changing climate. And then finally, my future work is to get a stronger connection with my economic estimation strategy, look at gains and losses in efficiency, and connect it to future climate scenarios. Thank you.